Let's review resistor concepts by solving some simple problems. Let's first review sheet resistance. Here I have two materials, two identical rectangles, 10 microns by 20 microns. On the top rectangle, I want to connect along the top surface and form a resistor terminal in this direction. And I want to connect along the bottom surface and form a resistor terminal this way. On the bottom material, I want to contact to the left side. I want to contact to the right side. Let's call this resistor R1. Call this resistor R2. Let's presume that the resistivity or the sheet resistance of this material is 20 ohms per square. So I want you to calculate the value of resistor R1 and R2. So put the video on pause and then come back and I'll give the solution. Okay, I presume that you've given this a shot, and let's see if we get the same answer. So recall that resistance is equal to the sheet resistance, R sub S, times the number of squares, which is the length of the resistor divided by the width of the resistor. In the case of R1, the length is this dimension, always in the direction of the current flow. And the width is the 20 microns. So let's solve for R1. R1 equals the sheet resistance, which is 20 ohms per square, times the number of squares, and the length is 10. The width is 20, so I have a half a square, times 20 ohms, so the resistance R1 is equal to 10 ohms. Let's do the same for resistance R2. So R2 again is equal to the sheet resistance times the number of squares, length over the width. Now here the length is this dimension. It's the direction that the current flows. So in this case we have 20 ohms per square times the length, which is 20 microns, divided by the width, which is 10 microns. So here I have two squares, and each square is worth 20 ohms of resistance. So R2 is 40 ohms. Let's solve another resistor problem. Here I have a battery of 10 volts applied to a resistor network. Here I have two resistors in series, and at the bottom I have three resistors in parallel. I want to find the voltage at this point. Let's call it V. And what I mean, if I put a voltmeter from ground to this point right here, what do I measure? What voltage do I read? So to solve this problem, you first want to compute the current flowing out of the battery. And so why don't you put the video on pause and see if you can come up with the answer. Then we'll solve it together. Okay, again, I assume you've given it a shot. And let's see if we get the same answer. So first, let's start at the bottom. I want to replace these parallel resistors with an equivalent resistor. So I'm going to start with the two resistors, 3K and 4K. And I want to calculate an equivalent resistance. And recall that the equivalent resistance is for any two resistors is merely the product divided by the sum of those resistors. So here I have the product, which is 3K times 4K divided by the sum, which is 4 plus 3. And in this case, if you do the math, that should be 1.71K. So now we have an equivalent resistance for this resistor. So let's draw the bottom part as two resistors. We have a 5K, and we've just come up with an equivalent 1.71K. So we want to replace these two resistors with an equivalent resistance. So again, we can take the product over the sum. 1.71 times 5 divided by the sum, which is 6.71, and I believe that is 1.27 k ohms. So now we have an equivalent resistance for the three parallel resistors at the bottom. So let's redraw the circuit. We have 1K at the top. We have 2K. And we've just computed an equivalent 1.27K. We know that this is ground. We have 10 volts up here. So we know that series resistors, to compute the equivalent resistor, we just add them all up. So we can come up with an equivalent resistor, 10 volts. This terminal's ground. 4.27K. So now we're at a point where we can calculate the current out of the battery. We'll call that I. And remember that I is equal to the voltage divided by the resistance, Ohm's law. So we have 10 volts divided by 4.27K, and I believe that is 2.34 milliamps. Remember that anytime the circuit has volts and k ohms, that your current comes out in milliamps. So let's go back up here. We calculated our current flowing here at 2.34 milliamps. So now we can calculate the voltage across this 1 k ohm resistor. We know that the voltage from Ohm's law is equal to the resistance times the current. The resistance is 1 k and the current is 2.34 milliamps. And again, when you use k in milliamps, the answer comes out in volts. So it comes out 2.34 volts across a 1K. So to get the voltage V, we need to subtract the voltage across the 1K from the voltage at the top, which is 10 volts. So the answer comes out 7.66 volts. Let's solve another resistor problem. Here I have a simple circuit. I have two 1K ohms in series, and I have a 10 volt power supply at the top, and I've grounded the bottom 1K. I want to compute the minimum voltage at this node. Let's call it V min. I want to assume that the 1K resistors have a 10% tolerance. So this resistor can either increase or decrease by 10%. And the power supply also has a 10% tolerance, so it can go up or down by 10%. So under these conditions, with the variance of the resistor and the power supply, what is the minimum voltage V min measured from ground across the bottom 1K resistor? So go ahead, put the video on pause, and then we'll come back and solve the problem. Okay, let's solve the problem. So if I have the minimum voltage across this network, that's going to be the case when this output voltage is at its minimum. So if I take 9 volts, which is on the low side, and I put that across my 2 resistors to ground. So what should this resistor here be? Now, if that were 0 ohms, it would be shorted to ground. So if it becomes smaller, if this becomes small, that causes the V min to drop. And if this becomes large, that develops a bigger voltage drop. So let's replace the top resistor with a 1.1K and the bottom with 0.9. And that's the condition for the minimum voltage. If we solve that, I believe that comes out 4.05 volts. Now let's do another calculation. Instead of calculating the min voltage, let's calculate with the same circuit and the same conditions, let's calculate the maximum power dissipation in either one of these resistors. Again, we have 10 volts plus or minus 10%. So let's determine what is the condition for the maximum power. Now we know that the power is equal to the current times voltage. So the maximum power will be under the condition of maximum voltage. So let's put 11 volts here. So we'll say the voltage is on the high side. And to make the current maximum, to maximize the power, the resistance will be at the minimum. This will be 0.9K. This will be 0.9K. So this will be 1.8K divided into 10 volts, and we can calculate our current. And we can take that current and multiply it by the voltage across this resistor, which will be half of 11 volts. The voltage drop will divide equally among these two resistors since they're the same value. So we'll have 4.5 volts times the current. If you do the calculation, the power should come out 6.1 milliamps times, I did something wrong, it should be 5.5 volts. Let's change that. 5.5 volts. So this comes out 33.5 milliwatts. So if we buy a 10th watt resistor, we should be fine. So a 10th watt would be 100 milliwatts, so we'd have about a factor of 3 safety.